Bar eye in Drosophila is X-linked and exhibits incomplete dominance. Wild-type females have an average of 810 facets in the eye, while homozygous bar females have an average of 59 facets. Heterozygous females have a kidney-shaped eye with an average of 447 facets. Males have either wild-type shaped eyes with 810 facets or bar eyes with about 60 facets. Why do females show an intermediate phenotype? Okay, for this example, females show an intermediate phenotype of 447 facets in between the 810 and 59 because females possess two X chromosomes and are therefore able to have and express the heterozygous phenotype, one X representing, or one X leading to 810 facets, the other would result in 60. But when you have your heterozygous and it is incomplete dominance, both are going to contribute to the phenotype of the female, and so she will have an intermediate of 447. Whereas the males, on the other hand, only have one X chromosome and therefore can only show one X-linked phenotype at a time. So they can either show the 810 or the 60. And that's why females have the intermediate, because they have two X chromosomes. Females, let's put it over here. Females have two X chromosomes, and our males will have an X and a Y, because this is X-linked incomplete dominance. Okay. An autosomal recessive allele, purple, results in purple eyes when homozygous. A female with bar but red eyes is mated to a male with normal-shaped but purple eyes. What are the expected phenotypic ratios in the F1 generation? So let's begin by defining our alleles. So in this case, we're going to use X big B for bar eyes, and we will use X little b for normal wild type eyes. Okay, and then we also have purple and red. We can see it is an autosomal recessive allele for purple. So purple will be little p, and red will be big P. Okay. What are the expected of our cross? Okay, so they say that we have a female with bar and red eyes. So she's gonna have bar eyes, so she needs to be both her X's need to have the big B. Because if she has a big B and a little b, now she's the intermediate, but she's not, she's the bar, okay? And then it says that she has red eyes. So we're gonna do big P and big P. Now technically, yes, you don't know, you wouldn't know if the female is homozygous dominant for the red or if she's heterozygous, but to make the cross easier, you're just gonna assume that she's coming in with a homozygous dominant. And for our male, it says that our male has normal shaped eyes, but they're purple. Okay, so he's gonna have normal, X little b, and then he's a male, so he'll have his Y chromosome. And then his eyes are purple, which is a homozygous recessive, so little p, little p. Now to do the cross, we're going to start with the eye shape phenotype, and we're going to cross those first. So cross the females, and then you go and cross your males. So we'll do the cross. Okay, Now we can see that we have, these are the offspring, so half of the offspring are female and half of the offspring will be male. Now in the female, all right, let's write that. Half will be female and half are male. Now in the female, we see that all of the female are heterozygous, which means that they're going to have the intermediate phenotype of 447. So we'll just write that they're all going to be XB and X little b. And all our male, however, are going to have bar eyes because they just have the big B on their X chromosome. Okay? Now we'll do the cross for the eye color. So your female has red and your male has purple. And as you would predict, all the offspring will have red eyes because the red allele is dominant to the purple. So we'll just say red for all of them. Okay. So our F1 phenotypic ratios here. We're going to have F1 is going to be your females who are heterozygous with the red eyes, and you're going to have males who have bar-shaped eyes who have red eyes as well. These are your phenotypes that you'll have in your F1. So this cross for the original parents would result in a 1-to-1 ratio. As you can see, you'll have half that are red and half that are red. So half to half is 1-to-1. 1-to-1 for the F1 generation. You'll have your females with red eyes and then your males with red eyes. Okay? Now, back to the problem. If one of the F1 males is mated to one of the F1 females, what are the expected results in the F2 generation? Okay, so now we're just going to go ahead and do the same thing that we did before. So we're going to have one of our males from the F1 and one of our females. So our female is going to be heterozygous for both traits, and then our male is going to be bar-eyed and red, heterozygous. Okay, so let's go ahead and do the cross for the eye shape. Okay, as we can see again, half of your offspring will be female and the other half will be male. However, unlike the other one, let's write this first. Half female, right? Okay, and then your other half is male. Okay, now however, in this case, you have females who are bar-eyed, and then you also have females who are the heterozygote. So in your female group, or in your female population, half of those will be bar, and the other half will be your heterozygote, which is the kidney-shaped eyes. Oops. Kidney. For your males, you have Your male population, half of those will be bar, and the other half of your males will be the normal wild type. Okay? Now we're going to do the cross for the color of the eye. One more time. Okay. And as you can see in this cross, you have these three who will express red eyes because they have the dominant allele, the big P. So 3 out of the 4, 3/4 of your offspring will be this or this. Either way, they'll have red eyes. And then 1/4 will have purple eyes. Okay. Now you need to determine the phenotypic ratios for your F2 offspring, okay? So we're gonna do this. Let's see, let's start it right here. Okay. F2 phenotypes. Okay. So let's begin with, let's just go straight across. You're gonna have half of your females, half of those will be bar, and then from that you'll multiply by the 3/4 to get red. So, okay, let's do it like this. If you want a bar-eyed female with red eyes, we can do it, let's see. Bar-eyed female with red eyes, so we can have it like this, okay? Because it can either be the little p or the big P. It doesn't matter. They'll still have red eyes. So if you want bar-eyed, and it needs to be a female because you got 2 X's with red, you'll do a half times 3/4, okay? So that'll give you 3/16. Now if we want a female, or females that are kidney-shaped eyes, which is a heterozygote, and still red, we're gonna do it like that again. We're gonna do a half times 3/4, which again is 3/16. Okay, now let's do it where we get a female with bar that has purple. Okay, so a female that has bar-shaped eyes with purple. You're gonna do a half times 1/4. Okay, so that'll give you 1/16. And then let's do the last one for the females. A female with kidney and purple eyes. So a female who has the kidney and purple. A half times 1/4. Another 1/16. Okay, so those are our female phenotypic ratios that we'll get from this cross. Now let's do our males, which is the same thing. So you want a male who has the bar-shaped eyes, but they're red, okay? So a male with bar who has red eyes, like that. A half times 3/4 is 3/16. A male who has, what are we doing next? A male who has normal shaped eyes but is red, okay? So a male with normal eyes but they're still red, a half times 3/4 is again 3/16. Okay, and I can't fit the rest, but it's okay. We'll put it over here. Now let's do a male who has bar-shaped eyes, but they are purple, okay? So a male who has bar-shaped eyes that are purple. A half times a fourth, which is 1/16. And then lastly, a male who has normal shaped eyes that are purple. A male with normal shaped eyes that are purple. Half times a fourth is 1/16. And then to make sure that you calculated everything right, just go ahead and add up your numerators. So 3 plus 3 is 6, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can't count actually. All right. 6 and 6, you got 12, 13, 14, 15, 16. There you go. 16 over 16, you know you did all of your multiplication and your crosses right. So these are going to be your phenotypic ratios for the F2. And that's it.